Homeostasis. What is homeostasis? Is any self-regulating process by which an organism needs to maintain stability while adjusting to conditions that are best for its survival. Example of homeostasis. Body temperature control in humans is one of the most familiar examples of homeostasis. Normal body temperature hovers around 37 degrees Celsius, but a number of factors can affect this value, including exposure to the elements, hormones, metabolic rate, and disease, leading to excessively high or low body temperature. The hypothalamus in the brain regulates body temperature, and feedback about body temperature from the body is carried through the bloodstream to the brain, which results in adjustments in breathing rate, blood sugar levels, and metabolic rate. In contrast, reduced activity, perspiration, and heat exchange process that permit blood to circulate near the skin surface contribute to heat loss. Heat loss is reduced by insulation, decreased circulation to the skin, clothing, shelter, and external heat sources. How does homeostasis work? Check out the vid I have prepared, and after that, that's all. After that vid, that's all.
Receptors in the skin and elsewhere, and they communicate changes to the hypothalamus of the brain. This control center can then coordinate the action of muscles, sweat glands, and blood vessels. These effectors can bring body temperature back to normal conditions. If, for example, body temperature were to rise, receptors would detect this increase and communicate this with the hypothalamus. The hypothalamus would then cause vasodilation of blood vessels going to the skin and the secretion of water from sweat glands to help cool the body, and this would return body temperature to normal. If body temperature were to decrease, receptors would detect this, and then the hypothalamus would direct the vasoconstriction of blood vessels going to the skin so that blood would be directed deeper into the body so that heat would not be lost. The hypothalamus would then produce hormones which would ultimately cause the contraction of skeletal muscle, which would generate heat and help restore body temperature to normal. Thus, homeostatic mechanisms must maintain body temperature within a narrow range. Should body temperature become too high, then a number of deleterious effects, such as the changing of the shape of proteins, would then inactivate their function. Should body temperature become too low, then many chemical reactions would not occur at rates fast enough to maintain life. And so homeostatic mechanisms must maintain body temperature within a narrow